told you anyway. Brilliant.
Cool. How's that? Okay, cool. Like Emina says, I am going to put a kind of a more technical or a kind of a practical view on what Emina was showing and talking about. And there's going to be kind of 3 levels to my talk, right? I'm going to go through it kind of at a high level. There's quite a lot of technical content. There's going to be stuff that I'll skip over. Feel free to ask questions afterwards or at another time. But I will try and not jump about too much and try and be clear. Last time I did this talk was the night of the big storm, and everyone's phones went berserk during the talk. So we'll see what the universe has for me tonight. I am a platform engineer first and foremost. I work for a company called Frontier. I have been in tech for 20 odd years, cloud starting with Azure for 12 or so, and then containers and Kube for kind of 7 or so. I, as I say, work for a company called Frontier. I'm also the CTO of that company and one of the founders. As I say, only 3 years old, but we work specifically around Kubernetes, around cloud automation, and data and AI as well. Specifically at the foundational level, right, of that, getting those foundations right around automation, around security, around observability, around maintainability, cost effectiveness and all that, right, as an enabler to kind of all of these different outcomes, right? But of all those things, Kubernetes, we tend to kind of drift further up the stack, right, in terms of helping customers get the best out of Kubernetes. I'm going to talk tonight about automating Rancher, but using Rancher as a vehicle to kind of talk about some of the approaches that we can take that Emina has talked about in terms of platform engineering, in terms of reusable components and applying standardization and getting that cookie cutter effect right, and thinking about the developer experience and how we make it easier for people to do the right thing. And that's the key for me to platform engineering, is making the easy thing the right thing, right? 3 parts to it, as I say. First is going to be about building blocks, which is going to be Terraform modules. Second is how we use those, and then the third is going to be multi-cluster apps with Rancher and with Fleet that Emina has mentioned. This doesn't feature CAPI, right? So this is obviously subject to change once kind of CAPI comes along, and I think when I look at some of the code just now, there's going to be some bits that we can point out that obviously could be replaced by CAPI in time, right? What that's going to look like then, and this is my last slide almost, is an initial layer of reusability of these common building blocks, right? And this is with an Azure slant on it at the moment, but there are various Azure services and resources here, resource groups, storage accounts, key vaults, AKS clusters. How we then take those and use them in a workload. So to take the individual building blocks, which are important and required, but at this layer, we're not being prescriptive about how these components are being used. It's reasonable to assume that the organization wants to use these components and services in different configurations and include some or exclude some. We want to apply some controls and some standardizations and some organizational prescriptiveness around how the org and how developers can use these without necessarily saying this is how you must bring them together, right? So it's about mechanisms to enable engineering teams, developers to be able to use those components and wrap them up into something, again, usable, right? And reusable. And Kubernetes cluster workload is a good example of that. An organization that might want to deploy multiple Kubernetes clusters for lots of good reasons. We want to make that easy to repeat as well, right? We want to take that blueprint, that standard happy path, that golden path that the organization has defined, and make that easy to reconsume again and again, right? And for me, just again, what Emina was talking about in terms of thinking about your developers and making that experience better, it's not for me about constraining developers or engineers and saying that this is the only way, but it's just about making easy ways, about making kind of straight, easy paths to traverse. There's always going to be scenarios where developers and engineers need to do something different, and that's fine. It's about clear signposting and about showing where the off-ramp is on those happy paths, and saying that's fine. If you don't want to reuse that component or that workload, here are the steps that you're going to have to go through. Here's the gates that you're going to have to get through in order to deviate, right? What we're then going to show, and then going to show as part of the demo then, is how we can use that workload, right? And we get that reuse to say that we've got a Kubernetes cluster workload. We want multiple instances of that have different versions of config, and that we can build mechanisms as platform engineers, self-service mechanisms that allow people to do that, to consume that workload, to set their own config and secrets and get that value, right? So they're not reinventing the wheel, they're consuming, but they've got that flexibility and those levers to be able to pull to configure that workload to do what they need it to do. And then we're going to put Rancher on there, right? And we're going to demonstrate then kind of using the GitOps feature in Rancher, which is Fleet. Again, to get that layer of reusability, right? To say you can write this application once, we can lower the barrier to entry for deploying applications onto Kubernetes clusters, and specifically multi Kubernetes clusters with features that are out there open source. That is my slides finished. I am going to go to some code. Can everyone see this? Is the font big enough, or I'll go bigger? Is it good? Yeah, okay, cool. So there's not many people in the room, so feel free to shout questions as we go, right? And again, apologies if I kind of skip over some of this stuff, but I could talk for a while, right? So I'm not going to. So this is an example, right, of a service catalog that we've built. So we've used GitHub. This is public. There's nothing private or secret in here, and probably nothing particularly new to most of the people in this room. This is about reusable Terraform modules. We have various modules in here which will look familiar to anyone that's used Azure. There's nothing particularly interesting inside each of these module folders themselves. There's some source code for Terraform, defining an Azure Kubernetes cluster, for example. There's some opinionated stuff in here, like on line 10, for example. We want to force Azure policy to be enabled. We're forcing some naming conventions. On line 2, we're forcing RBAC to be enabled with Entra ID integration on line 15, but nothing groundbreaking. But again, lots of code there, right, that not everyone wants to write all the time. And again, if we can package that up, we can standardize. The interesting thing about this repo, though, is that we've effectively turned it into a service catalog with some fairly straightforward GitHub action pipelines. And so what happens in this repo is that when the pipeline runs, it's able to detect changes in the individual modules folders under here and version these independently. And so you can see here are components that are all listed. This documentation is automatically generated. Each of the components have their own versions based on the detected changes every time the pipeline runs. And then once we merge those to main, the pipeline then creates individual GitHub releases for these Terraform modules and makes those consumable by developers. So if we click into Kubernetes cluster here, version 3.0.2, this is a GitHub release only for the version 3.0.2 of the Kubernetes cluster module. There's some documentation here. There's some code that's already customized, again, as part of auto-generated documentation, that we've injected the right version number. So the engineer can lift this text here and paste that straight into their code and get use of that module, right? And it's a really simple example of that reusable component approach, right? And that kind of bedrock of platform engineering, right? There are lots of reasons why this might not scale well in an enterprise, right? And including the fact that it's all in a mono repo, and you might end up with conflicts, and you might want to break that out into individual repos. But as a simple example, right, we can use one GitHub repo, we can get that service catalog effect, that single place where developers can come and browse, find what they want, select it, and relatively easily consume it, right, in a self-service way. So how do we use those? Again, I think most of the people in the room are technical, and so this won't come as much of a surprise, but we have a workload here, right? A virtual network workload, for example. And again, this is our second layer of reusability now. So we've got our Terraform modules, which are individual components. We now want to compose those together and say that the organization has an opinionated way where the virtual networks are deployed. So we deploy subnets, we maybe hook up log analytics, we want an identifier, there's maybe some routing tables that we always want to include to make sure that east-west traffic always traverses a firewall, for example, that kind of stuff that just isn't optional in the organization, right? We just want to do it all the time. There are no choices, whereas sometimes there are choices to be made, right, around what address space you want or what the identifier is, right? But again, documentation here, this is again a fairly simple example, right, and mostly for the sake of demo, but there's a README here, right? This talks about what this workload does. It tells the engineer or the developer what the requirements are to consume this, right? You need to set the following environment variables. You need to pass the following config. No secrets required, no known issues, and if you want to contribute, here's how you do it. In real world, we would probably want to scoot this README up into some sort of central repository of workloads and documentation, right? But we don't have that in this example. So this is the virtual network workload. It consumes those Terraform modules. So if I look at main.tf here, you can see that we're consuming that resource group module. We're pulling that from GitHub, and we're pulling the specific version release, and so we're reusing those individual components. I'm going to look at another example, which is the Kubernetes cluster. Slightly more complicated, obviously, because of the nature of deploying Kubernetes, but exactly the same idea. A README that explains how it can be used, what you need to provide, what the expectations are on the engineer and the developer to be able to use this workload and what it will do. And again, what the config is that you need to pass, and what's optional, what's not, if there are secrets required, any known issues, etc. This should be updated today. Did anyone hit the Azure thing that happened today with deploying AKS clusters? There's something that's changed in the versioned API that shouldn't ever change, that did today, that's broken the ability to deploy Kubernetes clusters using any version of the ARM provider in Terraform. So that little like API version that you stick on the end of the API calls apparently means not a lot, because it all broke today. So that would go in here, right? But it hasn't, right? And so again, the same principle then, right? We've got these workloads that are consuming Terraform modules. So we're at kind of the second layer here, right? And again, none of this will be a surprise, but you can see here now that I'm also consuming the Kubernetes cluster module, that 302 that we passed or that we consumed, that we produced, in GitHub earlier. I'm consuming that inside my workload, right? So we're building up that layer of reusability. And then we version this too, right? So this is a workload, it delivers some unit of business value. It's not just a resource group or just a storage account or a key vault. It's something that delivers combined business value. We've composed lots of things together. There's a Kubernetes cluster there, there's a resource group, there's some key vault stuff going on, there's some log analytics, and we need to version that too, right? And so we push these workloads just as packages, just as zips into a package repository, right? And so this starts to then form that second layer of service catalog. Again, real world, right? We'd need to dress this up a bit better. It would need to be bringing in the documentation, but as an example, right? This would be our catalog of workloads that are available. Our Kubernetes cluster workload is here, and we can see the versions that exist at the moment, and obviously the previously produced versions as well. We need to maintain that backward compatibility. We need to semantically version, make sure that our change logs and everything else reflect why our version was incremented. As a platform team, we need to, like Emina says, treat that platform as a product, right? We can't just change something without communicating that and providing that backward compatibility. We can't force teams into upgrading at the time that we say just because it's appropriate for us and convenient for us. We've got to think about that behaviour and that that experience, right, from the developer and from the engineer point of view. Demo time. What I want to show you is how I can use this Kubernetes cluster workload that we've got here to deploy 3 Kubernetes clusters and then bring those into Rancher. Because of time and also what happened today, I have pre-deployed my 3 Kubernetes clusters because it was a hack to make it work. But you can rest assured that they have been deployed. The way I've deployed those, and again talking about that kind of layer of reuse, right, is with a simple YAML file like this. And I'm not going to go into too much detail about this, but I'll show you what is kind of happening at a high level. This YAML file is just is for a tool that we've built, and it's very, very early, but the idea really is that we can define a set of workloads and drive pipelines from that. So the idea is that it's pipeline of pipelines. We would run our CI/CD pipeline in Azure DevOps. It would read this file, and it would then trigger the necessary workload pipelines to go and deploy that version of that thing, right, with the following arguments. So you can see here that I've got the same Kubernetes cluster workload being used 3 different times. It happens that I'm using the same version, right? But you can see that I wouldn't have to. I could change first or second or third to a different version if I chose, but I'm reusing that workload. And then on the left here, you can see I've got matching folders under config for each of those named workloads. So in this instance, I know what I need to tell and I know what I need to pass in terms of environment variables and config because the README on the workload has told me so. And so that enables me in my TFRs file here, for example, to pass the Kubernetes version and the subnet to drop into and the name of the cluster. You can guess what second says. Again, customization for that specific instance of that workload, right? This is where we start to kind of blend with what Emina was talking about with the CAPI API. The current approach in my Kubernetes cluster workload is obviously very Terraform heavy, and I'm using the Azure RM provider, and then I'm taking config like this and I'm feeding it into Terraform. Obviously what CAPI will eventually do in this example is potentially replace that layer, right, that Terraform part of that. And actually if there's configuration that I can store that I can then just feed straight to a CAPI API and build a cluster on that basis, then great, right? But today I'm not using that, right? So my 3 clusters have been deployed. I can prove that to you. I have my first, second, and third. Wow, good. I have my first, second, and third clusters here. Nothing exciting, vanilla Kubernetes clusters. They are not, I've not done anything to them. I've just deployed them and that's it, right? Before I click the pipeline button and cross my fingers, I'm going to talk about what happens then once the clusters join Rancher. So the demo that I'm going to show you is taking these vanilla clusters and then importing them into an existing Rancher instance that I've got at the moment. And Rancher has been configured with a fleet application, just a really simple Hello World Kubernetes application. Rancher has been configured to automatically onboard those clusters and immediately deploy that Hello World application onto those clusters. They should pop up. I should get a load balancer on each of these Kubernetes clusters, and it should hopefully say hello on the internet, right? I'm going to show you just quickly how that is going to work, or hopefully how that is going to work. I've got my Rancher server configuration here, right? Again, I'm using Terraform, and I'm not going to go too deep into this, right? But other than to say Rancher itself has a Terraform provider that we can use as soon as Rancher is deployed, whether that's on a Kubernetes cluster itself or on an OpenStack VM or somewhere else, right? As soon as that Rancher API is available, we can then use Terraform to then configure Rancher, including access control and groups and the applications that we want to deploy, etc. Some of that looks like this. So a single sign-on integration includes an Azure AD application and password, and then some Rancher-specific config, which is setting up that auth provider using OpenID Connect into Azure. I'm setting up some cloud credentials in Rancher as well, so giving Rancher service principal credentials that allows Rancher to interact with the Azure Management API to find Kubernetes clusters, to import them, and actually in this case what Rancher will do is it will install the Rancher agent onto the clusters that I point Rancher at. So it needs contributor access on those clusters so that it can then inject the Rancher agent onto the imported clusters, right? There's a couple of things in here that I'm not going to go through, but the one that I am going to talk about is how I'm doing the import in this scenario. So lots of different ways you can deploy Kubernetes clusters with Rancher, and obviously Aminia's talked about the fact that CAPI is going to enable us to be able to talk to a much wider range of providers and kind of infrastructure layers in terms of deploying Kubernetes, but for the moment, you can go into the UI and say I want an AKS cluster or an Azure cluster, or an EKS cluster or GKE, and obviously there are other providers as well, VMware, etc. You can do that in automation as well, so you can define your cluster as a Rancher resource using this AKS config v2 as an example, with many hundreds of lines of configuration options there to get that cluster to look just right. The third option is that you can deploy clusters, vanilla Kubernetes clusters, and then import them and effectively assimilate them, right? So they then become Rancher managed clusters. And what you end up with is exactly the same. However you go about it, there's no second class citizen in there. You end up with a cluster that's managed by Rancher. You get all the features and all the benefits from there on in, right? In this case, I'm using the import model here, right? And all I'm doing here is taking an array of cluster IDs that I'm passing in as a variable into Terraform and creating multiple Rancher 2 cluster resources as a result. The next thing then that's happening once the clusters are imported is that we're deploying a Helm chart, and this is where Fleet comes in. So there are two parts to my GitOps style application that I'm deploying here using Fleet. The first is the definition itself of the Git repo and where the application is coming from. So it's a Kubernetes resource. I'm using Helm to deploy it. I could have used Terraform. I could have not used Helm, but here we are. I'm pointing to my GitHub repo with my application in there. I'm telling it to correct config drifts so that if any application changes on the downstream servers, Fleet will correct that. Makes sense. I've got a branch spec in there, nothing particularly fancy. If I come back to GitHub for a sec and look at what that repo looks like, there's only a couple of things to talk about. The main one is this fleet.yaml file. So this is what Fleet is looking for at the root of that repo that you're pointing to. And lots of customizations available. I'm not doing anything particularly fancy here. All I'm saying on line 4 is that for any cluster that's in scope, I want you to pass a value into the Helm chart that you deploy with name cluster name, and I want you to take the cluster display name for that specific cluster as that value. And so we can get that customization of Helm deployments per cluster based on picking out variables and parameters in Rancher's config, in Rancher's view of the world, right, in Rancher's state. The Kubernetes application itself that I'm deploying is a really simple Nginx application. Simple deployment. There's one pod. I'm exposing a container port. I'm mounting in a config map. My config map is this, returning a 200 and saying hello. And my service is a load balancer, so Azure should create me a public load balancer, give me an IP address, and we should be able to hit the application on each of the 3 clusters. And then Rancher is pulling that together then and selecting those clusters based on cluster groups. So I've got 4 cluster groups in this file. 3 of them are using dynamic selectors, so I'm selecting zone labels, so corporate, platform, and shared services. but for the sake of demo, I have just defined more verbosely or more specifically the clusters that I want to target. So my application is targeting the demo cluster group, and I've obviously selected my 3 Kubernetes clusters here. I am going to run my demo. This is my configuration for Rancher. There are 4 clusters in Rancher already that you can see the 4 uncommented lines for, and then I've got my first, second, and third clusters here. I am going to uncomment. Come on. Cool. And I'm going to be naughty and run from a branch. Cool. Okay, so I'm going to try and pad before these clusters pop in. Left-hand side is the main Rancher UI, so I don't know if this is big enough actually. Yeah, okay. So left-hand side is the main Rancher UI, so 5 clusters in here at the moment. 4 of them are existing AKS clusters, and we saw the 4 IDs in that config file a minute ago. And then local at the bottom is the Kubernetes cluster that Rancher is running on. As I say, it's a bit inception-y, right? Because Rancher in this case is running on a Kubernetes cluster itself, which it is aware of and is managing, right? Other options are available, but that's what local is, right? And you can see my other 4 clusters here. Not going to go into a Rancher demo, right? There's lots of cool things it does in terms of multi-cluster management and the ability to, I'm not going to go into Rancher, right? On the right-hand side, you can see the fleet dashboard. We can see our Hello World application, which is the one that we configured in Helm. Currently, clusters ready are 0. 9 of 9 is a hangover actually in the UI, is a bit of a bug from me testing this demo earlier. But as we start to see our clusters being imported because our pipeline is running, we should start to see this fleet application being targeted at these 3 new clusters that are coming in, and then this should reset back to 0 and then should start to show us the application being installed to each of these 3 clusters that are coming in. And the use case here, I guess, this is a bit of a contrived one, but the use case might be some sort of security or monitoring or cost control apparatus that you want to be deployed on all clusters, for example. You have a fleet application, you target all clusters. When a new cluster comes in, that's it. They just get the application, right? Whereas, or it might be more specific to a specific business unit or something like that, right? But there are lots of use cases that this would satisfy. As I say, this one's a bit contrived. While those clusters are coming in, I'm going to show you what we've got over here. These are my 3 AKS clusters. I have a bunch of cluster IP services currently, but no load balancer services. Cool. You can see here that the 3 new clusters, or 2 of them, have gone green. So Rancher's imported them. Rancher's then been able to communicate with the Kubernetes API on each of these 3 clusters. It's authenticated with the Azure Service Principal. It's been able to install Rancher agent on those 3 clusters. And then those agents have phoned home, connected back into Rancher, and Rancher's then able to start pushing applications and policy onto those clusters, which is what you can see happening on the left-hand side. Resources coming up. 15. Yeah, cool. We've got 1 cluster ready already, 2 clusters ready. So if I go back here to our services now, what we should see is that at least one of these clusters should now have a load balancer service down at the bottom. And all being well. Cool. So hello from first. Hello from second. Third one didn't work last time. And hello from third. Cool. Nice. Successful demo. Right, so as I say, what we've shown then is that layer of reusability at the start, those individual building blocks, how we can compose those together to build, again, something reusable, but something that it adds a bit more specific value, that is a blueprint specific to that org for something they want to achieve again and again. And Kubernetes is a great example. Something like Azure Data Factory might be another, right, where you want individual deployments in different business units, for example, but you don't want to share one big one, because why would you subject yourself to that blast radius, right? And then we can start to deploy multiple instances and then use tools like Rancher to smooth out the operational overhead of using multiple instances of Kubernetes, for example, with value add on the top, right, which is services like Fleet that allow us to do GitOps style application deployment. That's me. Thank you for listening. Have to take questions if you've got any. As I say, I appreciate there's a lot of content there, but I hope it was useful, especially in the context of what Emina was talking about.
I just not when you really interesting. I like what you've done that and the model looks good.
Cool. Yeah, it is based on real world, right? But obviously there's things that you would do differently depending on the size of your org and team makeup and that kind of thing, right? I like the GitHub thing with the Terraform modules because it's so easy, like it's so simple, like it doesn't have to be frightening. The idea of reusability in service catalogs and platform engineering, it could be that simple, right? Just with that, starting with that service catalog, one Git repo, a couple of pipelines to auto-generate documentation, some well thought out documentation that allows some copy and paste, right? And all of a sudden you've got a self-service mechanism, you know. Cool. Thank you.
Two questions.
Oh, you?
Yeah.
Oh,
Sorry.
yes, great question. I was just thinking of the presentation and lots of information. So
Yeah, no, I know, there's lots.
Git commit, all that.
Yeah, no, I know.
The first one is integrating it with, because I see it, of course, any system you have to integrate with. I don't know, I'm just thinking of a use case that I have. You have a CDN with a provider, Fastly, Akamai, whatever.
Yeah.
And you also have your backend, Oracle databases and so forth.
Yeah.
How do you see that integration in this context, knowing that
Yeah.
it can be a bit tricky on that side? And the corollary question, which is related to security. So the overall thing, almost main thing when you bring that to your managers is it safe?
Yeah.
How safe is it?
Yeah.
And how can we instill a bit of security in that whole context?
Yeah.
If you could just share a couple of thoughts about that.
Yeah, sure. So on the integration side, I guess there's always a question around at what point do you wrap your hands around something, right? So at what point do you create a module or do you create a workload, right? And it's a really subjective thing. Like there are modules out there that I see on GitHub and in demos and things that have like got 25 resources in it, right? And they've got like 50 variables and all that, and that's cool, right? And I get the use of that. And there's a danger that you go the other way, right? And so one of the modules that we've got here is resource group, right? And you're like, is there really value in a module that just deploys a resource group? There's only 2 lines to a resource group module anyway. There's more plumbing than there are lines of code in that module, right? But one of the things about that is the ability to be prescriptive about the things you need to be. So naming convention and tagging convention is a big deal, right? So I'll get to your answer, right? But the really interesting thing there for me is that yes, like you could say to developers, go and use Terraform provider, go and use resource groups, etc., etc. Here is a naming convention. If they don't follow it, it's gonna be further down the road before they realise that, right? Because eventually you're going to get to a review board or something like that. Maybe you've got policies in place that catch that, and that's great, and you've shift left it on that, but maybe you don't. And maybe eventually you get to TDA and it's already been tested, and then someone's like, that's great, but it breaks the naming convention for our org, and by that point it's too late, right? So I think wrapping stuff at the right level is important in terms of saying these are the things that we're just not prepared to compromise on, and these are the things that you interface into. And part of that answer is that it's sometimes hard to figure out where to stop, right? So like databases are an interesting one, right? You know, is it a shared server with individual databases, or is it a individual server with specific databases? Do you couple those two things together? Do you not, right? So I think there are organizational specifics there, right, that kind of make it a hard question to answer generally. In terms of security, again, like I said toward the start, I think it's about trying to help people either get things right first time and early, or fail early as well, right? And part of that is, like I was talking about that golden path of saying, like, if you consume these modules, these have already been through organizational approval, right? TDA has seen them, security have seen them, the FinOps team have seen them, they're happy with the default VM sizes and all that stuff. You've got some validation so that folk can't deploy a 256 core VM without somebody asking a question, right? And so if you try and do that, then you fail early. And similarly, if you want to deviate from that, that's fine, but like start by going and asking the security guys and saying, look, I can't use this module. If platform don't have a good answer for why they're not going to change it to fit that use case, then look, you're going to have to go on your own, but go and talk to the security guys or girls straight away, right? Find out why, what hurdles, what gates they're going to have to jump through, what additional design authorities they're going to have to satisfy, right? There's complexity there, right? But I think that the stuff that platform engineering is attempting to do helps if it's done right. There's just I've worked with some orgs before where it just goes a bit off the deep end, and it's like, well, it's our way or no way, right? And then people just go underground, right? And they just find a way around it, and you always do, right? So there's that balance there. You need to make it work. And again, that phrase, make the easy thing the right thing, or the right thing the easy thing, whatever way you want to say it, right? But it's about that. And if you can nail that, then a lot of the problems kind of sort themselves to a degree, you know? Sorry, that was probably a long answer and probably didn't answer the question, but yeah.
No, it's true that there are pros and cons in all situations. What I've also seen is that developers are just want my platform up running.
Yeah.
If you have one file or just one line, they'll be just happy
Yeah.
with that. Or you can't do that, right? So
Yeah.
you have to wonder, like,
And it's a compromise on both sides, right? Like, I've worked in platform engineering teams. I'd be really happy, like, just pleasing ourselves and not worrying about it, and just like ramming it down in like developers' throats and saying, like, this is the way, but it just doesn't work. Like, it just fails really fast, you know? So there's got to be that. It's got to be a two-way thing, right? And actually, once you start to do this properly, then you need that enablement team, right? Team Topologies talks about that, about that enablement team, that bridge between a platform team and the consumers that can help the consumers consume without worrying about offending the platform team because it's their baby, right? And also can feed back, again, without there being a bun fight, and say, look, we've got some folk that are consuming this stuff, could be better, this was painful, that was painful, this documentation was rubbish, right? That middle link, that neutral party in the middle is important sometimes, because folk get emotional, right? It's true, right? Okay.
So, one of the reasons for like versioning through platform engineering is governance. And the question I've got around that is, when do you want things around like module versioning for that governance, and when do you want a more, Azure policy, top-down governance? How do you find that balance, and what kind of key things are you looking for that go, oh, we want to put this into module governance instead of a platform governance?
Yeah. Yeah, I think that there are definitely some things that when it comes to versioning, right, there are some benefits to those versions being in code, right? And so as a platform team, as a producer of that Kubernetes cluster module, right, today is a good example, right? If whatever turns out to be going on today with Terraform and Azure APIs and that, right, there will be platform teams that are, we're being recorded, right? There are platform teams that will not be having a great day because all their consumers are then saying we can no longer use this component, we can no longer deploy it, right? And in that respect, having a platform component that's versioned and the code and the version is captured into code makes it a really easy discovery exercise, right? To then go and say, okay, we know that this version of our workload, the Kubernetes cluster workload, is being deployed in the following places, right? And so version 3.0.2 was fine, but actually anyone that's using version 2.5 below, for example, needs to update this workload, right? And so that inner source model, it's the same with software components, right? You can bring that into platform, and we see exactly that thing happening with tools like supply chain vulnerability tools, right? Where with Log4j stuff, right? You scan BOM files and all that, and then you see that you're using this library version, and you've got a problem, right? So we can do the same thing internally with platform engineering because stuff breaks and APIs change and all that, right? I don't know is the answer to your question in terms of like at what point do you codify stuff like Kubernetes must use Azure policy and must be integrated into Entra, and at what point do you rely on kind of top-down mechanisms? I think. I think.
Signposts that you've seen in an organisation where it's like, oh, if you're doing this, you're better going that way.
Yeah, I think early visit, like it's about early, and it's about the shift left as well, right? It's about trying to make sure that people know early what they're doing that's wrong, or what's not going to make it to production, right? And you can do it with both, right? So I've worked in orgs where you've got a set of policy definitions and you've got different actions, or you've got different, I can't remember the term, but you want a warn effectively on a lower environment and then a block on a higher environment, right? And that's not to block innovation, right? Because actually you want engineers and developers to try something in a safe environment, and if it breaks policy, fine. If it's in a sandbox to a degree, right? Because you don't want to say you can't use that thing, like never use that thing because we don't think you should, right? Because there might be a good reason actually for the org that benefits the application or the team. You want to give you want to provide that environment where they can break things and they can do bad things safely and know that actually this is flagging on policy. I'm going to have to do something about this. I'm not going to get it to production in its current form. And I think that's where policy starts to get useful, right? So there are some things like Entra ID integration, for example, that we always want with Kubernetes clusters, but maybe, I'm trying to think of an example. Like maybe like a service mesh integration or something like that, I probably don't want to be as prescriptive about in the module. I maybe want to catch it, like in policy, if it's opening, I don't know, this is contrived, but if there's like a node port being opened on the cluster because somebody's installed like a Prometheus app or something like that, like I don't think I want to block that in modules. I want to catch it in policy though, and I want to warn in an early environment, and give the engineer an opportunity then to go to the policy owner and say, look, can we have a change here? Can we have an exception here? Can we talk about this?
So for me, what I'm hearing is that they're all tools on your road to life.
Yeah.
And you can try and put them in different places.
Yeah, it's about layers of protection as well, right? And I'm not a security guy, so to speak, but it's about layers, right? You can't fix it. You can't mitigate with one layer, right? Yeah.
Thank you.
Cool.
Brilliant. Okay. Thank you very much.
Thank you very much. Cheers.